2 months ago, a doctor told me I have to give up programming. And today, because of this guitar, I don't have to. That's how I felt when I was told I have herniated disc. If I continue to sit all day, the problem will not only come back, but will be even worse. The change the doctor offered me was something I would never accept. That's why, as a computer science student, I did what I always do with a problem: find a way to solve it. First, as I was trying to make sense of the situation, I decided to seek help from a fictional character I have looked up to since I was little, Tony Stark. So I rewatched the movie in hopes of taking inspiration. He interacts with the computer through holograms, which I'm not smart enough to create, but noticed they relied on sight. I went through the other senses, and while looking at my old guitar, I got an idea. When the alarm rings, this is a transfer of information that it's the next day and it's time to wake up. Well, what would the transfer of information look like with music? I envisioned myself playing the guitar and the computer listening to the music translates it to English sentences that are used to do my work as a programmer. Simple, right? The goal is when a note is played, the appropriate letter is typed as if from a keyboard. The guitar is electric, so I plugged it into the computer with the help of an audio interface. The data when I listen to the guitar is a series of numbers between -1 and 1. It's the same as working with a microphone. I found many formulas online and libraries to use, but they were too complicated for me to understand. I switched my approach and looked for a simple but unique solution. Instead of looking for the notes, I decided to try and detect the silence. And it worked. It was good enough for my purposes. Next, I had to figure out which note was played. But then I came across an article on how to program a tuner for a guitar. It was like all of a sudden a GPS device landed in my boat. It worked perfectly with my project and I didn't have to change much. The hardest part was deciding which note to which letter it should translate to. The keyboard has the QWERTY layout. The weight of having to invent a high quality layout for the guitar was heavy. Thankfully, I found a video of how a genetic algorithm can be used to create an efficient layout for the keyboard. In his video, he assumes the user will be typing in a certain way, called touch typing. With this assumption, we know exactly where the fingers are at any moment, which makes creating an efficient keyboard layout a lot easier. But there is no touch typing for the guitar. So from having to reinvent the QWERTY layout, I now had to reinvent touch typing but for a guitar. I decided to use only the first 12 frets of the guitar. Next, separate it into 3 sectors. In the start, the 4 fingers of the left hand are placed in the middle sector on either 3rd or 4th string. The problem I quickly realized is notes on the guitar repeat. Some can be seen once, some 2 times and others 3 times. This means when I have to type the letter T, it may be in 3 places. The keyboard on the other hand does not have keys that repeat. I decided to add priority to repeating positions of a letter. First I look in my sector on the string my fingers are, and 1 string above me and 1 string below me, because I can easily reach them. If the letter is not there, I look in the other sectors on the same 3 strings, because it's easier to move left and right than up and down. If it's not there, I then look in my sector on the other strings. And lastly, I look in the other sectors in the other strings. If at any moment I have more than one option, I pick one of them randomly. With this way of typing, my goal is for the hand to travel the least amount of distance. And magically when I compare a random layout to one from the genetic algorithm, a lot less distance is traveled. For the spacebar, I mapped it to any silent note. This means wherever I am, when I play any note without pressing too much on it, my program realizes it's a silent note and just writes a space. Here is an example path if I had to type these words. The layout is not good for programming because this is what is typed most of the time: special symbols and numbers. For this problem, I aim to combine it with my other project where I made English into a programming language. And here is the final result. I'm not good with the guitar, so right now I'm very slow with it, but in the future, the best case scenario I can probably reach is 40 words per minute, which is average for people typing on a regular keyboard. I believe this project will help because I can play the guitar standing up, and I hope that when I get good with it, I can even move around while coding, which was the goal in the first place, to make programming a lot more active.